Hello friends, this video on hydrogen part 18 is brought to you by examfear.com. No more fear from exam. Let's understand the organic exchanger method here. So here we use organic ion exchangers, and we have two different kind of ion exchanger for organic here. Let's just write first here. One we have is the cation exchanger, the other is the anion exchanger. We'll tell you what is this. So here we use cation and anion exchanger. So this is my cation exchanger. Let me write first now. This is my cation exchange resin. This is my anion exchange resin. The setup. I'll talk about the setup later. So we have cation exchanger and anion exchange. So what is this cation and anion exchange? These are nothing but my complex organic molecules. They are complex organic molecules. Complex organic molecules, and they are attached to either acidic group or basic group. Okay. We'll talk about acidic group. It can be SO3H group or COH group. We'll talk about basic group. It can be OH minus or NH2 minus. Correct. So my acidic group are the one which are capable of exchanging H plus ions, and they are called cation exchanger. So they are called cation exchanger, and these are called anion exchange. So let me write first. So I have written the cation exchange resin and anion exchange resin. So let me write these resins first. So if you see the cation exchange resin, it is something like big molecule with SO3OH in the end, or a big molecule with COH in the end. When we talk about anion exchange resin, let me change the color. So if you talk about anion exchange resin, it is nothing but these groups, a big group with OH minus or big group with NH2 minus. So these are my resins used, right? So I hope you understand this. My resins, my cation exchange resins and anion exchange resins. So this guy is capable of exchanging OH minus ion or NH2 ions, and this guy is capable of exchanging H plus ions, right? So these are my cations and anion exchange resins, correct? So now I'll start with the process. Just to understand what is the resins, they are nothing but a complex organic molecule which has an acidic or basic group attached. The acidic group can be SO3H or COH. The basic group can be OH minus and NH2 minus. The acidic group, the one which attached with acidic group, they are called cation exchange resins. For example, this SO3H or COH minus COH, they are capable of exchanging H plus ions. The anion exchange resins have OH minus or NH2 minus the end, and they are capable of exchanging OH minus or NH2 minus. Correct. So these are my acidic and basic resins. So let me start with the process. What happens from here? The hard water comes. Hard water comes. And here this is cation exchange resin, that is it has nothing but it will give H plus ions. And this is my anion exchange resins, it will give H plus. So it comes here, hard water comes here. You ignore this part now as of now. Hard water comes here and it is attached to H plus ion resin. So hard water is nothing but my calcium Ca plus 2 ions. So let me write the equation. So I have Ca2 plus hard water that reacts with this resin, this guy, So both has H, so I can write as H plus and this structure like this, some structure, right? H plus and this dot, right? This whole thing I can write as big like this, right? This is H plus and big dot. So when it reacts, it becomes Ca, and this big dot was whatever it was, it became part 2, and this becomes 2H plus. I can give it a name also if you want. If you are confused with this, let me give it a name. H plus resin becomes Ca resin 2 and 2H plus. Correct? So I got in this, you see what I got? I got H plus. Correct. So if it is a what do you call chlorine, so it will be Cl minus and SO4 minus, those things also will be here. So I will say this guy is H plus. And now this goes off here. Now this guy is an anion exchange resin, right? Because this guy will have H plus, Cl minus. I am assuming that my hardness is due to CaCl2 now. I'm just assuming in this case. So I took Ca plus 2, right? This is nothing but CaCl2. So I got H plus and Cl minus here. Now this H plus and Cl minus will react with anion exchanger. So here let's suppose I have the Cl minus, it will react with this guy, OH minus and some resin, right? OH minus long chain. So it will give you Cl minus and some resin, and it will give you OH minus out, because this guy is capable of exchanging OH minus, so it will exchange this with chlorine. This guy is capable of exchanging H plus ions, so this guy will exchange with calcium. So I'll get this. Now if you see, I got H plus here, I got OH minus here. So I might add H plus and OH minus, what you get is H2. And thus I get pure water. This is demineralized water. In this you add minerals to add to the taste. Correct? This is how the whole process is. Now, same thing here also, regeneration, because after some time my H plus resin is gone, it becomes Ca resin 2, right? Because after some time my H plus resin, this is H plus resin, this becomes Ca resin 2, and this becomes Cl resin. So these are all my resin which will not be used. I have to regenerate it. So what I do here is, in this case I pump in HCl, and in this case I pump in sodium hydroxide, right? Sprinkler. So the moment I pump it HCl here, what happens is my Ca resin 2 reacts with HCl, and it gives back the old resin back. So I have to write the reaction. We have space, so let me just write it here to change the color. So the reaction which you get is, I had my resin is Ca resin 2. The moment I react with HCl from here, it will give you CaCl2, right? Plus, if you see, H plus resin. This is what I'll get. Similarly, in this case, NaOH, I have my Cl minus resin. In this case, I'll react with NaOH. It will give me OH minus R resin. This is the resin which I was having old. Current back, and I'll get NaCl. So in this case, if you see, the regeneration works like this. Once you feel that the resins are exhausted, stop the process, regenerate it, remove the waste from here, because it will have all this NaCl and all. Just remove the waste from here. There has to be a pipe to remove the waste. Remove the waste, close the tap, again start the process. That is how it works. Hope you understand. So this is nothing but organic exchanger method, where we have cation exchange resins and we have anion exchange resins, right? Cation exchange resins has capability of exchanging H plus ions. Anion exchange resin has capability of exchanging OH minus ions. So we react calcium chloride, which is the hardness, with first with the cation exchange resins. So it becomes calcium is trapped, right? And then we have the chlorine. We have to react with again this anion exchange resin. The chlorine is trapped. Both calcium and chlorine is trapped, and we get pure water. And we have to regenerate this resin. So we'll sprinkle hydrochloric acid in the cation exchange resin chamber, and we'll sprinkle sodium hydroxide in the anion exchange resin chamber. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.